Okay. So redox reaction. So that means three types of free radical generation. So one is thermolysis, another one is photolysis, and one more is redox reactions. Okay. Uh, so thermolysis means by using a heat, one can generate a free radical. So for example, dibenzyl peroxide at 80 degree, there will be a cleavage here and also a cleavage here. Homolytic cleavage between the two oxygen bond between the uh, phenyl and carbonyl carbon. So initially two benzyl oxy radical, and after removal of carbon dioxide, phenyl radical is coming in the case of thermolysis. And in these are the few more examples. So this is again ditertiary. This group is called tertiary group. This also a tertiary group. Ditertiary butyl peroxide. So at 80 degree, there will be a cleavage giving rise to tertiary butoxy radical. And here, one of the methyl group should be the cyano group. Then we can say that aza isobutyronitrile. So this also, there will be homolytic cleavage here and here. So giving rise to isobutyronitrile. So here one of the methyl group should be CN. Then isobutyronitrile free radical is the octide. This will be the general one. So generally, dialkyl Haza group or diaryl Haza group on heating undergoes denitrogen giving rise to radical. So one more method is photolysis in presence of sunlight or UV visible light, a free radical is generated. For example, chlorine on irradiation with light, it gives chlorine radical. Similarly, bromine on irradiation with light, giving rise to bromo radical. And acetone in presence of sunlight, giving rise to acetyl free radical. And this acetyl free radical further undergoes decarbonylation and means homolytic cleavage between this carbon and this carbonyl carbon, giving rise to two radical, carbonyl radical and methyl radical. So this is about photolysis. And the redox reactions. Redox reaction means here oxidation reduction is happening. So copper is converting into a copper 2 plus by giving electron. So that electron is used to break the diaryl peroxide, giving rise to aryl carboxylate radical. This aryl carboxylate radical undergoes homolytic cleavage here, giving rise to neutral product, and then aryl radical as the radical formation. So this is about what is called as how the generation of free radical. Now let's look into the mechanism. Okay, what is the mechanism involved in a free radical mechanism? So normally any free radical reaction means it takes place in three ways. So one is initiation, another one is propagation, another one is termination. Initiation means how the radical is initiated. So propagation is also called as chain reactions. And the termination. The termination means there will be a formation of neutral product. Neutral product means it's a termination. So neutral product may be a dimerization or may be a formation of neutral product. So let's go one by one. Let's look into the what is called as initiation. So there are some radical reaction initiators. For example, AIBN means aza bicyclo aza isobutyrylnitrile. AIBN aza isobutyrylnitrile is one commercially available radical initiator. Benzyl oxy benzoyl peroxide is also a commercially available radical initiator. So what this radical initiator do? They will undergo homolytic cleavage, giving rise to radical initiation. So the obtained radical react with neutral molecule, giving rise to another free radical formation. So the obtained another radical can react with another neutral molecule, so can give rise to another radical. So that means it's a chain reaction. So termination means both are radical if they are combining, that will be the termination. So let's look into the mechanism. So mechanism of free radical reaction. Let's give an entry. Okay. So mechanism of free radical reaction. The mechanism of free radical reaction involves three main steps: initiation, propagation, termination. So initiation means, for example, bromine. So bromine, when it is irradiated with light, this undergo homolytic cleavage, giving rise to two molecule of bromine radical. And this is a light reaction. Similarly, if you want to this sunlight reaction, if you want means treatment with the H nu means heat, means light. Suppose under thermal condition, so this name of this compound is called benzoyl. This group is called benzoyl peroxide. This benzoyl peroxide, when it is subjected to heat, so what will happen? There will be a homolytic cleavage between these two carbon, between these two, and then between these two. That means there will be a liberation of carbon dioxide is the neutral molecule that will go out and forming a two molecule of phenyl radical. So phenyl radical is initiated is obtained from the homolytic cleavage of benzoyl peroxide. Benzoyl peroxide is used as a radical initiator. So this radical is formed in presence of heat. Heat means thermal condition. The obtained free radical, it may react with the neutral molecule. What is neutral molecule here? Is HBr is the neutral molecule. So this HBr in presence of phenyl radical undergoes homolytic cleavage, giving rise to benzene as the one product, and again radical will be the another product. This radical, what it will do? It can react with the one more molecule of HBr and giving rise to bromine. And again there will be a liberation of hydrogen radical. That hydrogen radical again react with the HBr and giving rise to hydrogen and bromine radical, like that. So what is called as chain reaction or propagation reactions occur. But in this step, what we are discussing, initiation. Initiation means how the radical is initiated. So for example, benzoyl peroxide on heating giving rise to phenyl radical as the product. So this is only the initiation. Okay. Similarly, bromine in presence of light giving rise to bromine radical. So these two are the example of free radical initiation. So for this initiation, heat or light is used as a source. So heat in presence of benzoyl peroxide, light in presence of bromine molecule. So instead of one can also use the AIBN. AIBN means aza bicyclo, aza isobutyronitride. That also can be used as a radical initiator. In presence of benzoyl peroxide, you can use aza. Aza means N double bond N. So in the then CN CH3 CH3. C CN CH3 CH3. That is called aza bicyclo aza isobutyronitride. So this is about initiation. I will go to the propagation. Propagation is also called as chain reaction. So propagation, here the propagation means obtained radical can react with the neutral molecule. This is a neutral molecule. What is the name of this compound? Name of this compound is propene. So how it will react? So this pi bond undergoes homolytic cleavage. There will be a new bond formation between CH2 and bromine. There will be a formation of radical on this carbon. So that's what I have written. So there is a free radical on this carbon. Now this free radical again react with the neutral molecule HBr. HBr undergoes homolytic cleavage. Hydrogen, it will form a bond with this carbon, and bromine forms a free radical. Again, this formed bromine can react with another HBr and give rise to Br2 and hydrogen radical. That hydrogen radical can react with one more molecule of bromopropene radical and gives rise to this moiety. So the propagation or chain reaction, it's a continuous process. How the continuous process means? There will be a possibility of forming hundreds or thousands of propagation steps between the initiation and termination steps, and they are called chain reactions. So with this, I will go for a termination reaction. So this will be the termination. How the termination? The two radical can undergo dimerization. Dimerized product is the terminated one. So this R radical and R dash radical can combine, giving rise to a dialkyl compound. Means alkane or aryl depends on the nature of the R group or R dash group. Similarly, here suppose if I am taking an example, methyl radical. So one methyl radical can react with another methyl radical, giving rise to ethane as the product. Similarly, the ethane radical can undergo dimerization, giving rise to butane as the product. Otherwise, what will happen? Instead of going for dimerization, if there is a loss of proton from this carbon, or not the proton, hydrogen radical from this carbon, then there is a ethene compound. Suppose this ethyl radical, if it is obstruct a proton from the another uh, ethyl radical, then there is a formation of ethane as the product. So this is about what is called as termination. So overall, what you need to remember, so a chain free radical reactions involves three steps. One is initiation, another one is propagation, and one more is termination. In the initiation, free radical can be generated from the commercially available free radical source such as AIBN or benzoyl peroxide. And once the radical is formed in a initiation, that can react with the neutral molecule, can generate another free radical. Another free radical can react with one more neutral product or radical pieces, giving rise to one more newly formed radical. So chain propagation or chain reactions occurs in the case of propagation reactions, and termination can be occur through dimerization or by the neutral product formation. So this is about what is called as mechanism of free radical mechanism, more particularly initiation, propagation, and termination. And one more thing you can remember, radical itself is a unstable species, but it is observed that it is happening through initiation, propagation, and termination reactions. So let's go to the another concept. That is called what general characteristics of free radical reactions. So reactions are similar whether they are occurring in vapor phase or liquid phase. So that means free radical reactions are same in the case of vapor phase as well as in the liquid phase. So they are unaffected. Free radicals are unaffected by the presence of acid or base or by the changes in the polarity of the solvent. So that means free radical does not changes with respect to acid or base or polarity of the solvent, as in the case of nucleophilic substitution reactions. So they are initiated or accelerated by the typical free radical source such as peroxide or light. So that means free radical reactions are initiated or accelerated by the typical free radical source such as peroxide. Peroxide means benzyl peroxide or AABN source, or free radical can be generated or initiated or accelerated in presence of light. So these rates are used, okay, the rates are used or reactions are stopped by substances called inhibitors. So that means what you call NO. NO is the inhibitor. So it will inhibit the free radical reaction. Oxygen is the inhibitor. It will inhibit the free radical reaction. Phenol is the inhibitor. It will inhibit the free radical reaction. Benzoquinone, this is also act as a free radical inhibitor reaction. So that means by using free radical inhibitor, one can stop the free radical reaction. So inhibitors are the substances which stop the free radical reaction. Then I will take one more concept. So halogen means hydrogen peroxide. Hydrogen peroxide. Hydrogen peroxide means H2O2 is called hydrogen peroxide. So what is the difference between the peroxide and hydrogen peroxide? So hydrogen peroxide means H2O2 is called the hydrogen peroxide. Then what is peroxide? Two oxygen. Okay, two oxygen containing substances or compounds are called peroxide compounds. So oxygen, okay, oxygen means O2. So oxygen itself, it will exist in the form of free radical. So that means oxygen double bond O. So in what will happen? Oxygen one radical, oxygen another radical. So that means oxygen itself, it can act as a free radical. Otherwise, it is a diradical. It is not reactive enough. This you can spell it as a enough. It's not reactive enough to obstruct the hydrogen. So that means oxygen itself is not enough to obstruct the hydrogen, but it is a trace of free radical. Suppose if oxygen is attached to a alkyl group, then what we can say that it's a peroxide. Okay, alkyl peroxide. This alkyl peroxide radical is having a tendency or capacity to obstruct the proton. So what I mean to say that oxygen alone cannot obstruct the hydrogen, whereas the alkyl or aryl peroxide having a tendency to obstruct the hydrogen. So that's what you need to take it from this paragraph. So here a radical or maybe alkyl or aryl group, when it is treated with oxygen, it gives alkyl or aryl peroxide. This alkyl peroxide, alkyl or aryl peroxide, when it is treated with hydrogen source, there will be this alkyl or aryl peroxide obstruct the hydrogen from the hydrogen source, giving rise to alkyl hydroperoxide. Alkyl hydroperoxide as the product. Of course, there will be a formation of radical. So this is a general example how the alkyl or aryl peroxide obstruct the hydrogen. So if we are looking into the particular example, cyclohexene was taken. Cyclohexene in presence of light, it can react with oxygen. So you know that in presence of light, so there will be a cleavage. Okay, cleavage. So what proton it is? It's a allylic proton. Allylic proton, you know that it's acidic in nature and labile. So because of that allylic nature of this carbon and allylic nature of this proton undergoes homolytic cleavage, forming a radical. That radical react with oxygen, giving rise to cyclohexyl peroxide radical. This cyclohexyl peroxide radical can react with one more mole or one more equivalent of cyclohexene. This obstruct the proton from the cyclohexene, giving rise to cyclohexyl hydroperoxide as the product. Cyclohexyl hydroperoxide as the product. So with this, I will go to the next slide. So next I am taking the few more examples. Name of this compound is called decalin and AABN. AABN is a radical initiator. So AABN gives isobutyronitril radical. That isobutyronitril radical so forms a radical on this carbon, bridged carbon. So the obtained bridged radical react with oxygen, and again it will take a proton, okay, or hydrogen radical from one more equivalent of the decalin, giving rise to decalin hydroperoxide. Decalin hydroperoxide as the product. Here I am written only the reaction. What you can do, you can write the mechanism how the decalin is converted into decalin hydroperoxide as the product. So name of this compound is called tetralin. So tetralin, when it is treated with oxygen in presence of light, so what will happen? This proton is called benzylic proton. This of course this also a benzylic proton. So benzylic protons are acidic in nature. So in presence of light, this benzylic proton undergoes homolytic cleavage, forming a radical. That radical react with oxygen, so giving rise to hydro tetralin peroxide is the product. So one more example, paracymene. So this is again naturally occurring compound. Paracymene is the product. So paracymene in presence when it is treated with oxygen in presence of AABN. AABN is a radical initiator. So what will happen? So there will be a cleavage here, phenyl radical is obtained. So the when there is a cleavage here, the forms free radical here as well as here. This radical can react with oxygen, giving rise to intermediate means byproduct like this, and this is also a one more byproduct. So in this, what is happening? So two of the hydrogen is replaced with oxygen. Okay. So these two are the byproducts obtained when paracymene is treated with AABN with oxygen. Okay, so you tell me up to this, is there any doubt? Hello? Hello?
No, sir.
Huh? No doubt?
No, sir.
Okay. So I will go to the next slide. So here, this is a ether molecule. So suppose if there is a alpha hydrogen is present to the ether molecule, then there will be the obstruction of alpha hydrogen radical. So that means what will happen? Ether molecule, if they contain alpha hydrogen, such ether molecule undergoes reaction with free radical reaction with oxygen. So what is happening? There will be a cleavage, alpha hydrogen cleavage, homolytic fashion. So giving rise to radical here. That radical react with oxygen, and this hydrogen radical react with one more oxygen. So giving rise to uh, a what is called as a rearranged product. So what you can say that, of course, this is an ether and this is a peroxide. Hydro, ethoxy, peroxide will be the product. And one more thing, hydrogen peroxide, H2O2, decompose further to generate radical which starts new reaction. So that means this is a hydrogen peroxide. Of course, R may be a, R, if R is equal to hydrogen, then it's a hydrogen peroxide. Suppose if R is equal to alkyl group, then it's called alkyl hydrogen peroxide. If R is equal to aryl, then it is aryl hydrogen peroxide. So decompose means homolytic cleavage between the two oxygen. So R means alkyl oxy radical. If R is equal to R, if R is equal to alkyl, if R is equal to aryl, then aryl oxy radical. Of course, this is a hydroxyl radical. And what will happen? Suppose the obtained alkyl or aryl oxy radical, this has a tendency to obstruct a hydrogen radical from the hydrogen source. That means this RH group means alkane undergoes homolytic cleavage. So if it is undergoing homolytic cleavage, hydrogen can form a bond with oxygen. That is how alcohol and free radical alkyl radical is generated. So with this, I will go to the next slide. Formation of peroxide. So this is one peroxide. Okay. So peroxide means oxygen containing compounds. Okay. Peroxy group or O group is called peroxy group. Suppose if there is a radical, then peroxy radical is the general structure of this moiety. So usually peroxide means two oxygen containing compounds are called peroxide compounds. So let's look into the how the peroxide compounds are forming. So here I am taking one reaction. So if R dash is equal to alkyl or aryl, then alkyl aryl peroxide. Alkyl aryl peroxide, when it is treated with alkane or arane, when it is in presence of cuprous halide. So what is the obtained compound? Dialkyl. So if both R and R dash is alkyl, then it is dialkyl. If R and R dash is equal to aryl, then diaryl peroxide. If one is alkyl, another one is aryl, means alkyl aryl peroxide. It's a general reaction. So general reaction means alkyl or aryl peroxide, when it is treated with alkane or arane in presence of cuprous halide, it gives dialkyl or diaryl or alkyl aryl peroxides are the product. So let's look into the mechanism. So this is an alkyl hydrogen peroxide. alkyl hydrogen peroxide, when it is treated with cuprous halide, there will be homolytic cleavage between the oxygen and hydrogen, forming a alkyl or aryl peroxide radical. Alkyl or aryl peroxide radical, when it is treated with the alkane or arane, giving rise to alkyl or aryl hydroperoxide as the product. And of course, there is a formation of radical. Okay, alkane or aryl radical is formed. This alkyl or arane radical, if it is reacting with one more molecule of alkyl peroxide, then there is a formation of alkyl aryl peroxide or dialkyl peroxide or alkyl aryl peroxide. So this is about how the peroxide is formed in terms of general example. So now I will take a particular example. So what is the particular example? So you can observe that an alcohol. So more particularly, I am taking how the cyclic ether is formed. Say hydroxy group, and this position is called alpha carbon, this position is called beta carbon, this position is called gamma carbon, this position is called delta carbon. So that means delta hydrogen. Okay, of course, this carbon contains hydrogen. Delta hydrogen containing alcohols. Delta hydrogen containing alcohols undergo cyclization in presence of palladium tetraacetate. This is not 2, you make it as a 4. So palladium tetraacetate in presence of light or heat, giving rise to tetrahydrofuran. So this is a reaction. And if you are looking into the mechanism, this position is alpha, this is beta, this is gamma, this is delta. So that means delta hydrogen containing alcohol. Delta hydrogen containing alcohol, when it is treated with lead tetraacetate, what will happen? So in presence of light, this delta hydrogen undergoes homolytic cleavage and forms a, not the homolytic cleavage. So you know that lone pair present on this oxygen or the bond pair between the oxygen and hydrogen can react with this palladium, and acetoxy is going out. That is how an intermediate is obtained. So the obtained product, when it is heating, when it is subjected to heating or when it is subjected to light, so there will be a homolytic cleavage between the lead and oxygen, so giving rise to radical like this. So at this moment, delta hydrogen can undergo homolytic cleavage, so giving rise to radical here, and this hydrogen radical is moved from here to oxygen, forms a bond intermediate like this. At this moment, this lead triacetate, means more particularly radical, triacetoxy lead radical can form a bond with this CH2. So that is how the bond formation between the carbon and lead. So now, so this step is a not the free radical reaction, it's a nucleophilic substitution reaction. So the lone pair present on the oxygen or the bond pair, it will attack the CH2 group, and this lead, it is going along with this bonded pair. So that is the reason one of the acetic acid, one of the acetoxy group will picks up this proton and going out as a product. That is how lead acetate is obtained. So what is happening here in this free radical reaction, lead tetraacetate is converted into lead diacetate. What it means? So lead is undergoing reduction, and gamma means gamma hydrogen containing alcohol is converted into tetrahydrofuran. So this is about what is called as the cyclic ether formation in presence of lead tetraacetate, more particularly when it is accelerated by heat source or light source. Is there any doubt? Any doubt up to this? Hello? Hello?
No, sir.
Okay. I will go to the next slide. So free radical substitution reactions in alkanes. So this is one alkane. Alkane, R group should be alkyl group. Then only it's alkane. If R is equal to H, then it is a methane. If R is equal to methyl, then it is a ethane. If R is equal to ethyl, then it is a propane. So alkyl group, when it is subjected to chlorine in presence of heat or light, so what will happen? A alkyl is converted into alkyl halide, and hydrogen chloride is a byproduct. Let's not worry about this. Okay, so this is a reaction. So what is the reaction? Alkyl, a alkane, when it is when it is treated with chlorine in presence of heat or light, it gives alkyl halide, means alkyl chloride as the product. So let's look into this reaction in a stepwise manner. So stepwise manner means initiation reaction, propagation reaction, and termination reaction. So in this initiation means how the radical is formed. So the chlorine in presence of heat or light, it gives a chlorine radical. So I will go to the next slide. The obtained chlorine radical, it's react with RCH2H. Instead of writing RCH3, I am written as a RCH2H. So this CH2H undergoes homolytic cleavage in presence of chlorine radical, giving rise to alkane radical and HCl neutral product. This alkane radical can react with chlorine. Okay, so this alkane radical makes chlorine to undergo homolytic cleavage, so giving rise to RCH2Cl as the neutral product, and chlorine will be the free radical. So this is again a propagation step. If we are looking into the termination step, two radical, so means alkyl radical and halide radical can combine, can form a neutral product. Similarly, chlorine radical can react with one more chlorine radical, can form a neutral molecule. Similarly, two alkyl radical can undergo dimerization, giving rise to dimer product. So this is how the a alkane, okay, is converted into alkyl halide when it is treated with chlorine in presence of heat or light. Okay, this is about what is called as reaction at aliphatic carbon or sp2 carbon atom, or reactions of alkanes with the radical. Okay, so maybe what I will do, let's look into the order. Okay, means harder means primary radical. This is called a primary carbon, and this is called secondary carbon, and this is called tertiary carbon. Order of obstruction of hydrogen. So tertiary is more it is possible to abstract the hydrogen easily compared to the secondary. Secondary is more easy of the hydrogen abstraction compared to the primary. So this is all because of the energy involved. In the primary carbon CH bond, it's 98 kilocalorie per mole, and secondary 94 kilocalorie per mole, and tertiary 92 kilocalorie per mole. So that is the reason this subtraction is more easy compared to the secondary compared to the primary. So then, if we are looking into the rate with respect to the halogen, the rate of abstraction increases with the decreasing bond dissociation energy as shown above. Fluorine is greater than chlorine, chlorine is greater than bromine, bromine is greater than iodine, the decreasing order of the reactivity of the halogen. So this will be the decreasing order of the reactivity of halogen. So let's look into the few more points. So chlorination reaction is not for preparative purpose because alkyl carbon in the molecule is chlorinated. Bromination is much more reactive than the chlorination. It is possible to brominate tertiary position selectively. It should be remembered that greater the reactivity of the species, the less is the reactivity, selectivity. So fluorine reacts too violently, involving breaking of carbon-carbon bond. Iodine reacts too slowly, so that is the reason no practical interest. So now tell me, up to this, is there any doubt? Any doubt?
No, sir.
Okay, so let me look into the one more concept. Here, you can make a D as a silent. Hammond's postulate. So Hammond's postulate means here what is happening? This is a ethane molecule. So ethane molecule, when it is treated with chlorine radical, so it will form an intermediate like this. So here, what is the thing you more particularly when delta H is equal to negative. So here the less radical formation character. So H and Cl. So that means Cl radical cannot obstruct the a primary uh, primary hydrogen. So that means less radical formation character is observed when delta H is equal to negative. Suppose same ethane moiety when it is react with bromine. So here there is a high radical formation character. So it's because of the halogen, not because of the alkane. Here in both the case, alkane is same, but halide is different. So in bromine, delta H is equal to positive. In chlorine, delta H is equal to negative. So in bromine case, high radical formation character is obtained. So that is the reason ethane radical is obtained and HBr, a neutral product, is obtained. So this is about what is called Hammond's postulate. Hammond postulate means a chlorine radical, when it is react with ethyl, it leads to a less radical formation character, whereas a bromine radical, when it is reacting with ethane, it forms a high radical formation character. That's what you need to mention, and you need to mention delta H negative and delta H positive. So with this, I will go to the next slide. So here I'm taking the stereochemistry part. So stereochemistry of the radical substitution, the alkyl radical having planar structure. alkyl radical having a planar structure. When it is attacked from the both the side with equal views, from that leads to a racemic mixture. So that means you know that butane. So more particularly, this is methyl proton and this one is methylene proton. So methylene proton of the butane, when it is react with bromine, so giving rise to butane, butane free radical. This butane free radical, it is having a planar structure. Since the butane free radical is having a planar structure, the bromine radical can attack from this side as well as this side. If it is attacking from this side, it will you will get this compound. Means here there is a conversion of prochiral into a chiral moiety. Conversion of prochiral into a chiral moiety in terms of free radical. So the radical, if it is attacking from one side, you will get one enantiomer. If it is attacking from other side, so that means this side, you will get other enantiomer. So here racemic mixture is the product. So what you need to say here with respect to the stereochemistry, suppose a radical is formed a planar moiety, then that time a radical can attack from the either side, giving rise to racemic mixture. Okay. So then I will go to the next slide. Okay. Okay, what I will do, I will stop at this stage and I will continue in my tomorrow's class. So up to this, if you have any doubt, you can ask me. Hello.